Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good morning and salam sejahtera for all of you.
Morning, sir.
It's
Morning,
very glad to see you again in this week for the last session of this week. We have two more sessions, one Ficon and one non-Ficon. We're going to continue to finish the topic about the Voltaic cell. Actually, we finished the topic. Today, we are going to have some exercises about Voltaic cell. And the second hour, we are going to do different activity. All right, as usual, before we start our lesson, let's pray first. Pray, begin. Pray finish. All right, now already 14 students here. Any absent today? Hambali, is he okay now? You don't know about Hambali?
Hambali still sick.
Still 6.
Yes.
All right. From previous exercises, there are still 2 students didn't submit the answer. One of them is Ali Mubin. Mubin, you haven't submit the exercises last week to Google Classroom. Huh?
I will submit it later.
All right. Please submit it here today. After the lesson, if you already finished it, please submit it. And I'm going to check who is going to be absent from the teachers. Oh, Yogi is for vaccine, yeah? Yogi is vaccine today. So 2 students are still 6. One student 6, one vaccine. We still have how many students? 3 more students or 4 more students not here. Any information? Huh? No information?
No.
Siapa yang nggak di sini? Okay, now they are coming. Oh, atau saya mulainya terlalu cepat. Jam berapa kita harusnya masuk?
Asar 9.40.
9.40, isn't it? All right, now 16 student. Harusnya kan 21 ya dengan saya. 21 kurang 2 berapa? 19 ya. Masih ada 2 student are not here. Who's not here? Selain Yogi dan Hambali.
Wahyu dan Rido.
Rido.
And Wahyu.
Rido and Wahyu. Rido, any information? No, Wahyu? No, okay. Okay, let's do some review what we saw last lesson on Tuesday. All right, Iki, can you explain us what you learned from last lesson? Wahyu came. Rido now is not here. Yes, Iki, please.
Okay, sir. In the last lesson, we have learned about electrochemistry. There is current that from positive to negative, and electron from negative to positive. Thus,
Right.
electrochemical cell is divided by two. There is Voltaic cell and electrolytic cell.
Right.
In the Voltaic cell, the reaction is spontaneous.
Okay.
And then we learn about cathode and anode. The cathode is positive and anode is negative. In the cathode,
Right.
there is
That's why in Voltaic cell, isn't it? Cathode positive, anode negative. It is in the Voltaic cell, isn't it?
yes.
Okay. Okay. Stop in here. Stop here. Next student, Mirza. Can you explain how the Voltaic cell work?
Okay, sir.
You can use bahasa if you have difficulty with English.
Jadi voltaic cell itu pertama menghasilkan electricity yang berdasarkan dari akumulator atau baterai contohnya. Mereka bekerja pertama ada katot dan anode. Nah, katot itu duan yang gens elektron yang mendapatkan elektron dan anoda yang memproduksi elektron. Nah, jadi voltaik ini kerjanya berbalikan dengan arus listrik pada fisika, yang dimana arus itu ke positif ke negatif, sedangkan ini negatif ke positif. Mungkin seperti itu, sir.
Thank you. Next student, Denny Rahman.
Yes, sir.
Can you explain a little bit about the function of the salt bridge?
Pakai bahasa, sir.
Yes, please.
Jadi fungsi jembatan garam itu untuk menstabilkan antara larutan yang di anode sama di katot agar tidak terlalu positif dan tidak terlalu negatif.
Which compartment is more negative?
More negative in katot.
Yes. All right. So the ions from the salt bridge, ion positive will go to the cathode, ion negative will go to the anode, isn't it, Denny?
Yes, sir.
All right, thank you. Okay, guys, do you remember all of that? All right, so we're going to continue to solve problem. I gave you one question actually last lesson. Let's come back to that question and try. We're going to solve it, and then we are going to continue with different question. All right. What was the question? Is silver and magnesium, if I'm not mistaken, isn't it? We were having silver and magnesium. Silver, silver plus electron, and silver, and given E0 reduction is equal to 0.84. And we have magnesium, 2 plus electron, 2 electron, and it's produced magnesium. E0 reduction is equal to minus 2.37. This was the question. And the question was, we're going to find the E0 cell for this, isn't it? How to find the E0 cell? Let's remember the formula. What was the formula? E0 cell is equal to E0
of cathode minus E0 of anode.
right. E0 cathode minus E0 anode. Now the problem is we are going to choose which one is cathode, which one is anode. As I told you last lesson that the E0 cell is always positive for a voltaic cell. So that's why the one with have more positive E0 cell will be cathode, and the one will have less positive E0 cell will be anode. So here we can understood that when we see the E0 cell here, the comparison, silver will be more positive, so silver will be cathode, and magnesium will be anode, isn't it? Cathode, which reaction is taking place? It is reduction. All right. In anode, oxidation. All right. Now, when you put the value here as 0.80 volt minus negative 2.37 volt, and when you add here 0.80 plus 2.37, you're getting 3.17 volt. So this is the E0 cell that we got. All right. This is part A question. In part B, what was the question? We're going to write the reaction in electrode and the total reaction or the cell reaction. It's very easy. Now I'm going to write first the reaction in cathode. The reaction in cathode, I can write like this. Cathode is reduction is taking place. It is a cathode is silver. So silver Ag, and E0 is given as 0.80 volt. Sorry. All right. This is in cathode. In anode, as we know that anode is oxidation reaction, but the given here, the given reaction is reduction. As you see, 2 plus to 0 is reduction. So in writing the electrode, the reaction in electrode, you have to reverse this second reaction because it is occurring oxidation, undergo oxidation. So I have to reverse the second reaction to make it oxidation. Mg 2 plus 2 electron. Then what happened to the E0 when you reverse the reaction? The sign of E0 cell also will be reverse. From negative, it will become a positive 2.37. Right. Okay. Now, after we write the reaction in anode and cathode, this is the reaction in anode and cathode, how we can find out the cell reaction? It's very simple to know the cell reaction. Just you will add these two reaction in cathode and anode, then you will get cell reaction. Sorry. When you add these two, you're going to have a cell reaction. But before adding, you have to consider the number of electron, the transfer electron between this cathode and anode. There must be the same. Here we have 1 electron, and here we have 2 electrons. So to balance the number of electrons, the second reaction and the first reaction, the cathode reaction, have to multiply by 2. So you will get here 2 here, another 2 here, and 2 here. So when you add these two reactions, these electrons are canceled to each other because they are the same. And at the end, we can write down the cell reaction. 2Ag plus Mg reducing Mg2 plus plus Ag, 2Ag, sorry, 2Ag. So this is our cell reaction. Now, what will be the E0 cell? As we see here, when you add these two, you'll get the same number here, 3.17. Now, what is important here, in a E0 reaction, here, when you multiply the reaction, the E0 will not be multiplied. When you multiply the reaction, the E0 will stay the same. It will not be multiplied by the coefficient. It is different from delta H. Last year, you learned about delta H, isn't it? When delta H, when the reaction are multiplied, the delta H also will be multiplied, isn't it? But in E0 is different. When you multiply the reaction, E0 will stay the same, right? It will not affect the E0, just affect the coefficient of the reaction. That's the difference. Right. Is it clear? Do you have any question? All right. Can I clear? All right. We are going to solve another question now. Another question is like this. Given that, why the colors become like this? Given that the cell notation like this, the second given notation is (1.1 volt). The question is, calculate the standard cell potential for please calculate the standard cell potential or E0 cell for Mg, Mg2 plus, Zn2 plus, and Zn. The given data is 1 and 2, two data, yeah. Thank you, Vishnu. Very good. Very quick here. Ashley answered the question, and that's true. Thank you, Vishnu. Lutfi, thank you. Rizky, thank you. Alfie, yes, thank you. Yes, thank you, Danny. Very good. Thank you for the answer, for the one who got already the answer, and that's true. Okay, how to solve this is very simple actually. Sorry, it's getting slower, my laptop or the connection. Okay, to answer this, first you're going to write down the, look at this one, mg is here in the left and zn in the right. So for the first reaction, mg is in the left, so it's already true. So the first reaction, you will not do anything, just write here mg2 plus Cu2 plus Cu, and E0 is given as positive 2.71 volt. And the second one here, look at here, zinc is in the right side in the anode, but sorry, in the cathode. Here, zinc is in the left side. So we have to convert the second reaction. We just reverse the reaction. Now, Cu is become in the anode. So we are going to write the oxidation reaction for Cu. And zinc is in the cathode. Reduction of zinc. E0, because I reverse the reaction here, of course, E0 also will be reverse. So it will be minus 1.10 volt. When I add this two reaction, Cu is cancelled because they're the same. So it's remaining Mg2 plus and Zn2 plus Zn, and E0 is equal to, when you sum this, you'll get positive 1.61 volt. So this is the answer. All right. Is it clear? All right, thank you. Can I clear? All right. Another question. The question is, are this reaction spontaneous? Are this reaction below spontaneous? A. Cu plus 2Ag plus. Come on. Reducing Cu 2 plus 2Ag. B. Cu plus 2H plus. You have to use the data from the table to solve this one. C. Okay, for part C, there is a hint. I will give you the data that is not given in the data table, maybe. The hint is for Fa through plus electron is equal to Fa2 plus. E0 for this one is equal to 0.77. Oh, this is the hint for part C. All right. Try to solve. Are these reactions spontaneous or not? All right, there are some answers here. Vishnu, thank you. Lutfi, yes, thank you. Vishnu and Lutfi always be the two first to answer the question. Thank you. The others, please. Yes, Daud, true for part A, part B, C. Come on, guys, you can use the data table. You have to use the data table, actually. Without data table, you cannot solve this. All right, another answer, guys? Prayoga, thank you, that's true. Okay, for the first one, we have to compare copper and silver. Okay, what was the reduction, E0 reduction for copper? Berapa ini nilainya?
Point 34.
Positive 0.34, isn't it? For silver?
$0.799.
0.8.
Yes, sir.
Okay. When you compare this, so silver will be cathode, isn't it? Because it is have more positive. Copper will be anode. So silver will be reduction. Don't forget. And anode will be oxidation, isn't it? But when you see here, silver is reduction. Yes. Copper is oxidation. So true. So this reaction is spontaneous. Yeah. The same time, the same thing for here. Copper 2 plus and copper E0. We know that positive 0.34. And this is for hydrogen. Hydrogen plus. We know that the E0 for hydrogen, you don't have to see. We know that it's 0 because it is C, yeah, standard hydrogen electrode. So 0.34 and 0. So this copper must be in the cathode. And this hydrogen in anode, isn't it? Cathode reduction and anode oxidation. So copper reduction, copper oxidation here in the reaction. So this reaction is not spontaneous, non-spontaneous reaction. Non-spontaneous. Karena nggak sesuai dengan data ya. Harusnya copper itu turun, copper itu jadi katoda, terjadi reduksi. But in the reaction, copper oxidation. So it is not fixed with the data, it's non-spontaneous then. And the next one, Fe is given 0.77, copper. Let's copper, see the copper. Copper, we know that it is E0 is 0.34. Which one is bigger? Iron is bigger, isn't it? So it is cathode. And this is reduction, of course. And here is anode and oxidation. So iron cathode, iron reduksi. So this is true, yeah? Iron reduction, copper oxidation. So this reaction is also spontaneous. All right, is it clear? Very good. There are so many other questions in your book, so you can refer to your book and try to solve more questions. In the second hour, I'll not give you a question, but I'll give you assignment. Okay. But for this one, we know that Voltaic cell is very beneficial in our life. It can be used in a battery, it can be used in an accumulator, and it produces electricity because of the transfer electron that happening from the anode to the cathode, from the oxidation to the reduction. Yeah, there is a transfer of electron. So it's very, very beneficial. We have to thanks to the God because already created this kind of concept, this kind of reaction that it can be very beneficial in our life, isn't it? The two application of this reaction is in accumulator and battery. Imagine that if there is no battery in our life, so it's very difficult, right? Even to charge your laptop or smartphone is maybe very, very difficult. If there's no battery, maybe you have to plug your smartphone every time to the electricity. So it's very difficult. That's why thanks God for this creation of a reaction that we can have a battery in our life. So in the second hour guys, saya akan beri tugas pada kalian untuk membuat IG post. IG post isinya apa? Yang pertama tentang baterai ya dalam kehidupan sehari-hari ya, penggunaan dari Voltaic Cell dan kehidupan sehari-hari, baterai sama baterai kering ya tadi ya, baterai kering dan aki. Jadi nanti akan menjelaskan aki itu secara kimia seperti apa dan bagaimana digunakan dalam kehidupan sehari-hari dan informasi tentang aki. Begitu tentang baterai. Setiap siswa tidak akan mengerjakan dua-duanya. I will divide the odd absent number will be accumulator and the even absent number will be baterai kering, ya dry battery. Jadi nanti akan membuat konten IG ya. And you're going to upload to your IG post, and then the link of the IG Instagram you're going to send to me the link, and you have to finish it in this 45 minutes. So it is not homework. This is a 1 hour lesson. So just you have to manage your time, and no need to very what's difficult design or no, we don't need the design. Just the important is the information that you give, but if you got a good design, of course there will be extra point for you. Okay, is it clear? In the second hour you're going to finish. Please don't submit it late. As usual, at the end of the lesson you're going to submit it. That's enough for today for the second lesson. See you next lesson. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
If you have any question, please ask. Kalau ada yang nggak ngerti di tentang baterai atau aki,